Game development. Bring your ideas to life to build an immersive and engaging gaming experience. To build your own dream game, because AAA game studios couldn't, you first need to create assets. An asset is any piece of digital content that can be used to build the game world, such as 2D sprites, audio files, animations, and more. Then you start programming inside the game loop. It works like this. The first step is to process any input from the player. For example, a left arrow key can tell the game that the player needs to move left, and so on. The next step is to update anything that relies on said input. The final step is to render or draw the updated state to the screen and return to the first step. This will result in an infinite loop called the game loop. A game, fundamentally, is just an infinite loop consisting of a scene and a camera. A scene is like a game level containing all the assets, while a camera is the point of view of the player. But here's where things get tricky. Most games require physics, animations, and sound effects to function properly. This makes games complicated from a development standpoint. Luckily, the immense challenge of game development has been democratized with game engines, such as Unity and Unreal, which provide all these features and take a cut of your revenue once your game becomes successful. Not to mention, your game will work on mobile, PC, and consoles from a single codebase. This was game development in 100 seconds. If you want to see more videos like this on game development, hit the like button. And now it's time to go beyond and create our own game from scratch. One of the most popular game engines is Unity. It has been around since 2005 and is developed in C++, but allows developers to write their code in the more approachable C#. We'll also examine concepts like delta time, collision detection, and game state. In addition to this video, you can reference the full article on adipowdy.com and the source code on GitHub. To get started, install Unity Hub, create a new 2D project, and then open the editor. I'm using version 2022.3 for this video. You'll be greeted with a 2D scene that contains a camera. To create a game of Pong, let's add a square for the ball and 2 more squares for the player and opponent paddles. Then hit Y on your keyboard to move, rotate, and scale the objects, or use the inspector window to do it numerically. Set the background by selecting the camera and changing the projection size to 10 units. Additionally, you can also change the environment color to black. At this point, our game doesn't have any functionality, but let's run it anyway. Hit the play button and notice how the shapes don't do anything. To make this game playable, let's add a script component to the player paddle object. It contains a class with 2 methods to help implement your code. Start is called once when the game first loads, while update is called every frame of the game loop. At the top, we'll declare a variable for move speed, which represents how fast our paddle should move. And with the serialized field attribute, its value can be modified through the editor. Now we want the paddles to move in response to the player input. The way you implement this is through input.getKey, which checks if a key has been pressed, and input.getAxis, which returns a range between -1 and 1 to account for the direction we want to move in. Then to move the paddle up and down, we can change its position through the transform.position component of the game object. We'll just update the current position with the speed variable multiplied by time.delta time. Time.delta time returns the time passed between the last frame to the current one, and incorporating it in the movement of game objects make them independent of the device frame rate. Hit play and you should be able to see paddles moving, but they also go past the screen. That's because we don't have any bound setup for the movement. To restrict movement, we first need the screen's dimensions, which can be easily obtained by the screen.width and height properties. Since these values are in pixel units and all our calculations are done in Unity space units, it's our job to convert them, which we do by camera.main.screen-to-world point. The paddle's position itself is determined from its center point, so to keep the top and bottom half of the object within the screen, we also need to incorporate its height, which can be obtained by spriterenderer.bounce. Then we can use the math.clamp function to limit its movement between the top and bottom edges of the screen. From the Unity editor, we can also see that the paddle now moves within the confines of the screen. That's pretty cool. But now we can update the ball script to give it a random velocity every time the game starts using the random.range function. The ball also needs to bounce whenever it hits a surface. This can be done by checking for collisions between the ball and the paddles or the top and bottom of the screen. Collision detection for the screen edges is straightforward. We can get the screen and object bounce like we did for the paddle. From there, we can negate the ball's vertical velocity whenever it touches that part of the screen. This can be done quickly with a simple if statement. Set the horizontal velocity to 0 and hit play to test this, and you'll see that the ball is now moving up and down on the screen. To check for collisions with the two paddles, Unity gives us the onTrigger enter 2D method, which automatically passes the collider as its argument. Inside the function, we simply negate the ball's horizontal velocity to move it in the opposite direction. Return to Unity, add box collider 2D components to all three game objects, and check the isTrigger. Notice how Unity automatically fits them according to the size. Then to enable collisions, add a rigid body 2D component to the ball. Set the body type to kinematic and freeze rotation. Hit play and notice how everything is working except the opponent's paddle. Go to the opponent paddle script and this will work the same as our play paddle, except that we want it to move automatically without any player input. We check if the paddle's position is above or below the ball to achieve this. Declare a property for the ball at the top and assign an actual value to that property by dragging the ball object to it in the editor. Then we update the input variable accordingly. We also want the paddle to move only when the ball moves towards it. Now we need a game manager to keep track of the score and check when the game ends. Add two text game objects from the UI section to display scores on the screen. You'll be greeted with a small pop-up if it's your first time. Hit import and notice that the canvas game object is created automatically. Inside the inspector, set the scale mode to scale with screen size to enable responsive behavior and match width or height to 0.5. Position and size the game objects and add a new empty game object for the game manager. Add a new script component and create properties for the ball, the text objects we've made, and two more for the scores. We want to update the scores whenever the ball moves past the left and right edges of the screen. To do this, we'll compare the screen bounce with the ball's position, and then return to the ball script and add a public method to reset such position. To serve the ball, we want to check which player's turn to serve and launch the ball in the opposite direction. From there, we can ensure the ball only moves when the player wants to serve by updating its position only when they hit a button. We can do this by changing the update function to something else and calling that function from the game manager only when necessary. Inside the game manager, create a new property for the game state and update the ball only when the value is set to the play state. Whenever a point is scored, change the state to the serve state and change it back only when needed. This can be easily done by creating a new function which checks if the return key is pressed. From there, we can end the game when 5 points are scored by creating a new win or lose state and creating new functions to display the winner and to reset the game. We have now built an entire game from scratch using Unity and C# with basic game development principles. Remember to leave a comment and suggest what you want to see next.